Day to you, and I'm happy to be with you once again. In this video today, I will be explaining the chi-square analysis, and my name is Dr. Omilani Nathaniel, and this channel is called Ìsuntéré Educational TV, and I would love you to like and subscribe to the videos and also share. Ìsuntéré means drops of water that makes the ocean. So little by little, we develop knowledge concerning different fields. So today I'll be explaining chi-square analysis. And before I do the SPSS demonstration, I will want you to learn about how SPSS does it, but what is chi-square itself. So the point is that chi-square is a non-parametric statistical method that is used to analyze categorical variables or data. Either they are nominal or ordinal. They can be used to actually, so the assumption of chi-square is that there is no assumption of normality, because if you find the mean, you will discover that the mean value that will be obtained will be the same. For example, let's say we assign 1 to preferring meat pie as breakfast, and we assign 2 to preferring puff puff as breakfast. Whichever group and the number of distribution of that group, what we are going to eventually have is the mean of 1, because everybody will choose meat pie and they are 100 times 1 divided by 100 will give us 1. If we take meat pie 2 and we have 50 people there, it will be 50 times 2 divided by 50, it will get 2. So that which we have assigned as the value will be the value of the mean. So as a result of that, we don't assume normality. So it gives us whether there is a difference in distribution. For instance, let's talk about preference for school, parental preference for school. Some parents, we have 100 parents. So chi-square will give us the following information. If we have, don't let me say 100, let's say we have 90 parents. That is and we have 2 types of school. We have state-owned school, we have federal school, and we have private-owned school. You will discover that we will expect, theoretically, that 30 of those parents will choose private, 30 will choose federal, 30 will choose state-owned school. But as we go on with our research, it may surprise us to realize that the parents, they will not follow our expectation. There may be 23 in one, 27, and the frequency distribution. So when we want to see that, we will know that, oh, there is a different. So the chi-square will give us the information about the disparity that is seen between the observed frequency distribution and the expected frequency distribution. That's the first thing chi-square will do. It will give us the distribution of the observed and expected. The next thing is that it can also give us independence testing, whether there may be a variable association between them. For instance, if we have religion of parents and their preference for school type, maybe it gives us, the religion is also categorical, and the school type that they prefer is also different like that. So then we have the statistical significance. It will tell us whether the observed difference are likely due to chance or represent or true relationship in the population. So like I have said, chi-square um, is applicable to do a bit of relationship testing between categorical variable, gender, product references, educational level. We have all of those. We also equally have survey. For example, if we have a questionnaire and we are looking at customer satisfaction level of the hotel services, satisfied, not satisfied, highly satisfied, and we have given to customer over time, we may use that chi-square analysis to actually determine whether the customers are satisfied for each of those items. Maybe the food, we have an item for food, we have an item for support staff in the hotel, and so many other things that are categorical. In the social sciences, it's also used in health study, because can use to determine relationship between risk factors and health outcome treatment across patient groups or disease prevalence pattern. This is very important for us to, but don't forget that if we are doing chi-square, your chi-square must be telling us the nature of your data is categorical. And there are two types of chi-square analysis. The first is the test of independence. That means we want to check whether a particular variable is associated with another one. For instance, we want to check whether the religion of the parents affects the school, the type of school they select. We want to check whether the marital status of a woman determines the type of lunch that he gives to the child. Maybe we qualified the lunch into nutritious by some parameters, not nutritious by another parameter. By the time we want to compare these two types of incidents, we will now need chi-square analysis to check whether maybe a single mother can give a more nutritious meal, married, divorced, and all of those. The next type of chi-square is the goodness of fit test. That means we did just to determine, there are no two variables we are checking, that does this particular data fit the expected pattern of frequency distribution. That's the first one. So chi-square test of independence, like I have explained, it examines relationship between uh, two categorical variables by comparing the observed frequency in a contingency table to frequency expected if the variables were completely independent. For example, is there a relationship between gender and academic performance level? The test creates a cross tabulation of the two variables and calculate whether the pattern of responses differs significantly from the random chance from what random chance will produce. So the null hypothesis that is to be stated is that gender and performance are independent, and we can have alternative hypothesis that says gender and performance are related. But that is the purpose of test of independence, as it were. So this is a form of data, gender categories, uh, the performance that matches them. So the goodness of fit chi-square It compares the observed distribution to a single categorical variable to an expected theoretical distribution to determine if they match. So, for instance, you can say, do students show equal preference across 4 academic student subjects, or preferences differ significantly? So, like I have said in the earlier part of this video, the parents factor is taken away. We are just looking at only school type preferences. So we expect that 90 parents will do 30-30, but the observed may differ. So we will check whether there is a significant difference between the expected and the observed. So the goodness of it tells you if the differences are statistically significant. So when we are doing chi-square analysis, there are some assumptions that we must not violate. Number one, the variables, either you are using the independent test or goodness of fit, they must all be categorical. No continuous variable is expected. So we can have gender, we can have yes or no responses, we can have written categories, we can have color preferences. The next thing is that the independent observation. Each observation must be independent. One participant response cannot influence another, and no repeated measures from the same individual. For instance, you cannot say you prefer private school and public school. You take one. You can't take the two, as it were. So then the expected frequency requirement in each cell should be greater than or equals to 5. If the cells have expected count below 5, consider combining categories or using the Fisher exact text. The next thing is the frequency data format. Data must be in frequency count, not percentages, not proportions, not mean. Each case contributes to one cell, as it were. So this is the manual computation of chi-square explained. That's the chi-square symbol, and we have the sum across all categories, the bracket of the observed frequency minus expected all squared, and all of that. So how does it work? Each category can be calculated through the square differences, and these are very important. So when you are running a chi-square on SPSS, you go to analyze, descriptive, drop down menu, you do cross tab and all of that. So at the end, we have come to the end of this. So it is now for us to demonstrate it. And I want you to follow the demonstration in this particular video. Very, very easy. This is a data set. You can see here we have representations. This data set belongs to pre-service chemistry teachers, and these chemistry teachers are expected to actually determine whether to choose a particular representation or analogy that they will use to explain a particular concept. But based on the nature of concept, their choices were categorized, that the person that chooses this is an expert, the person that chooses this is a novice, and all of that. So there are 5 categories. So the first thing is we want to run a goodness of fit chi-square analysis. So you will go to analyze, and when you go to analyze, you will see non-parametric tests. Under the non-parametric test, you will go to legacy dialogue, and under the legacy dialogue, you select the chi-square analysis. So going back, we have representations, that is in 5 categories. Let's drop it in the variable test, and you may wish to go to option and continue. I will explain the expected values this below, but it's not for us because we have already categorized manually before we brought this data to SPSS. So what is left for you to do is to click on OK. And as you have clicked on OK, the information concerning the data set will come up to you. You know that the total number of entry is 126. There are 126 people there. And look at this table, frequency. Novice, the expected is 25.2 if we divide it. Now, but we have 29 novices, so there is a deviation from the expected for novice level. Look at basic. We expected 25.2, but we have 19 novices. There is deviation, but the deviation is higher than what we have for the other one. For developing expert is very close, 23 to 25.2. The experts that we found that gave experts, they were 36, and the exemplary people were 19. So this is the chi-square results. You can see the chi-square value is 8.44, and the degree of freedom is 4, because we have 5 categories. So the degree of freedom is usually n-1. So as a result of that, the degree of freedom is 4. And the significance that we obtain is 0.077. So this is the result that we have actually obtained. So what do we now make of this result? It tells us that the disparity between the observed distribution across the 5 levels, 5 types of explanation that the teacher can provide is different from the expected. There is a disparity between the two. So this disparity is not significant. The disparity in the distribution of this is not significant. So what they are saying is that the observed and the expected are almost the same. They are not significantly different from each other, not too far away. And you will notice that except for the expert group, where we have a residual of 10.8, that's the only group. But across the group, the residual difference is not so high. So for us to say that there is no significant difference. So this is how to run the goodness of fit type of chi-square. Now, let us say we want to do independence. Now, you go to descriptive. When you get to descriptive, under analyze, you will select the cross tab. And when you select the cross tab, you put the representation in the row. You may put school type in the column, and you may decide to choose the statistics that you are interested in. Let me just select the chi-square statistics and just say continue. Let's not do other things in this particular video. We may wish to do cell and click on observe and expected and just say continue. We may decide to do away with other things and just we may decide to choose our display clustered bar chart so that we can see the graphical representation of what we have. So this second one that I'm running is for the goodness of fit. Then you just click OK. So we have more table in this particular chi-square analysis. Now, the table results is going to come. It's still running. But what I want you to realize is that you can see the table is here now. So the table will give us a bigger table. Look at it. For those people that provided novice representation, the expected count, the total number of people that gave novice representation are 29. and the expected count is 29. But the real count that was observed for state 6, then 17, then 6. So you can see between the novice level, what we did for goodness of it, they did it to check the spread. The same thing for basic count. This is the distribution that was expected for state and federal, but the observed is different from that. Same way as we go on like that. So we have the distribution for state and federal, the expected for 50, 26, 50, but here we've seen the real one. So this is independent chi-square. So he did what we did in relation to state and federal. So now the next thing is that to check this Pearson chi-square. So what this tells us is that there is a significant difference. The degree of freedom is 8 and the chi-square value is 42.606, and it is significant. So in essence, what we can do by interpreting this result is that there is actually a relationship between the type of school the pre-service teacher comes from and the kind of explanation the pre-service teacher provides. For example, look at the number of people who provided exemplary explanation in the federal institution. They were constantly more than the privates in experts, in developing experts, except for developing experts where we had 11 counts for states. But you discover that in all cases, we have more people from federal institutions providing expert explanations and exemplary explanation. So as a result, we can say that the people in the federal, they are likely to, their distribution, they provided more expert and exemplary explanation compared to those in the state. It could be parents and choices of school, but it has to be categorical. I would love to hear from you. Thank you very much for watching this video. See you, and share and subscribe.